Welcome to Philosophy of Value Workshops number 16 of Series 8. The question for today is mathematics a creation of the mind, or does it exist independently in the world? Reading from one of my works, The Pursuit of Value, Chapter 6, Section 11. In general, I'm advancing a culminating principle of life as a will to value leading to a sufficiency of value. I explain what that means in my other podcasts and writings. Yet this principle of value builds on an awareness of value as a constituent of consciousness. So this series, 8, has been about explicating the phenomenon of consciousness. We have recently approached the understanding of consciousness in different ways. These have included different theories of consciousness like physicalism, dualism and functionalism. We have looked at schools of thought like phenomenology, existentialism and Buddhism. Issues about consciousness have included free will, objective knowledge and mysteriousness. Last week we asked whether information exists in the world independently, or is it a product of consciousness? A number of arguments indicated that counterintuitively information is dependent on consciousness. These included the views of Locke and Kant, logical and computer data, DNA and postmodernism. But we didn't examine mathematics as the most objective form of information as data. So we'll examine the possibility of mathematics as objectively independent today. What I and mathematicians mean by mathematics as objectively independent is difficult to understand. It isn't whether mathematics has ontological substantive existence like matter. It doesn't. It isn't whether mathematics is universal and normative. It is. It's about whether mathematics exists prior to being discovered, or is it something we create or invent with our minds? This question goes to my interest in the creative capacity of consciousness. The idea of creating mathematics with our minds may seem preposterous, but there are different views on this. Locke regarded mathematics and number as an objective primary quality of the world. Kant thought time and space to be products of the mind, but that they were explicable in terms of mathematics. Gottlob Frege, Edmund Husserl and Roger Penrose hold the independent and objective existence of mathematics. Gregory Chatin, George Lakoff and Steven Weinberg advocate a more pragmatic and empirical approach. Heidegger and Wittgenstein hold that existence of mathematics depends on the presence of consciousness, but they don't explain explicitly how mathematics can be dependent on consciousness. One question is, if mathematics is invented by our minds, how can we explain its manifestly objective properties? That is the central question that we'll tackle today. We first need to say that mathematics as an external and objective reality is an extremely compelling idea. But Gottlob Frege had to argue against logical psychologism, that logic is just a way of thinking. Michael Dummett held that mathematical truths must ultimately be grasped intuitively. And Bertrand Russell spent 100 pages trying to prove fundamental equations like 1 + 1 = 2. As a new foundation for mathematical logic was proposed in the axiomatic set theory of W.V. Quine. But neither this nor the explanation of mathematics as a system of tautologies has resolved the problem. Mathematical realism has also been undermined by the discovery of non-Euclidean geometry. Similar problems arose with Kurt Gödel's incompleteness theorem and Alan Turing's considerations. And many other mathematical anomalies can be found, such as Church's undecidability theorem, Turing's halting theorem, and Tarski's truth theorem. These anomalies encouraged a subjectivist account of mathematics. In line with this view, Wittgenstein produced an anthropocentric or constructivist mathematics. That is, he insisted that mathematics is a human invention and not a pre-existent reality that we discover. Wittgenstein argued that it is at the very least wrong-headed to say with the Platonists that because a straight line can be drawn between any 2 points, the line already exists even if no one has drawn it. That is to say, what is in the ordinary world we call a possibility is in the geometric world a reality. One might as well say, and Wittgenstein suggests, that chess only had to be discovered, it was always there, unquote. He came to this anthropocentric view by his rejection of mathematical set theory and infinite extensions of number. More specifically, he says that we have invented the contents of mathematics, such as symbols, finite sets, axioms, rules of inference, and irrational numbers. Yet this claim is contentious, and I don't understand it, as I'm not a mathematician. But I similarly argued that we have invented the contents of information and data. Wittgenstein thereby informs us of supposed errors in our understanding of mathematics, and he points out the apparently mistaken objective status attributed to mathematics. But he doesn't explain what the anthropocentric status of mathematics actually is. Neither does he explain the normativity of mathematics, how the normativity of mathematics can be otherwise established. This is a task that remains to be completed or even undertaken. David Hilbert attempted to explain the objectivity of mathematics by the exclusion of contradictions. Hilbert wanted to eliminate the intuitivism and tacit assumptions from mathematics. But the mathematical means by which he attempted this was strongly contested. And in my view, we still haven't established the ontological basis or status of mathematics. This was a question of particular concern to Husserl. Heidegger also presents us with a radical perspectivalism concerning number and mathematics. Yet he had a more subjectivist view than Husserl, which found expression in his notion of Dasein. Heidegger writes that 2 times 2 equals 4 as a true assertion is true only as long as Dasein exists. Then the proposition is no longer valid, not because the proposition is invalid as such, not because it would have become false, and 2 times 2 equals 4 would have changed into 2 times 2 equals 5, but because the uncoveredness of something as truth can only coexist with the existing Dasein that does the uncovering, unquote. This is his considered position, enunciated almost 3 decades earlier in his Being and Time. But this doesn't explain how Dasein uncovers or brings the apparent objective reality of mathematics into existence. Neither does it explain how Dasein brings mathematics into the world through its own presence. Yet in my view, the notion of Dasein introduces a proxy for consciousness, and I believe that mathematics can be explained with the structures of consciousness. To clarify the question of subjectivity, we need to distinguish three issues. The first is the requirement of proof of basic mathematical propositions such as 1 + 1 = 2 tackled by Russell. The second is whether mathematics is discovered as an aspect of the world, or is it created out of our own subjectivity as held by Heidegger and Wittgenstein. The third issue is how can subjectivity produce an objective system like mathematics? And why are the fundamental equations of mathematics the way that they are? One argument for objectivity is that mathematics seems to make predictions about the future discoveries in physics. Roger Penrose, for example, points to Paul Dirac's equations predicting how physical reality will turn out. Peter Higgs also predicted Higgs boson particle, confirmed 50 years later with the Hadron Collider. Mathematicians like Max Tegmark, David Volgon and David Gross take this to mean that mathematics is objective. That is, correspondence between mathematics and physics means that we discover rather than invent mathematical reality. Yet the uncanny prescience of mathematics may also be because of a shared anthropocentricity of mathematical understanding. And as we just saw, Heidegger and Wittgenstein argued for the anthropocentricity of mathematics, and it will give further arguments for such anthropocentricity shortly. We previously saw how different colour perceptions and other accounts provide explanations of science, and some mathematicians also hold pragmatic rather than objective accounts of mathematics. Steven Weinberg, for example, takes a pragmatic and empirical approach. This is due to the existence of mathematical inventions and unprovable theorems. These may be chosen for their elegance, symmetry, or consistency. George Lakoff similarly speaks of natural capacities of the mind where metaphors are grounded in logic, and that these metaphors are thought to be set in the preconditions of understanding. But metaphors of understanding and mental capacities again imply anthropocentric explanations of mathematics. Yet such pragmatic and anthropocentric accounts do not yet amount to a definitive argument. Yet they nevertheless open the door to the possibility of subjective accounts of mathematics. Gerald Edelman and L.E.J. Brouwer attempt to provide such subjective accounts of mathematics based on time. Edelman refers to Brouwer's view that number derives from what he eccentrically calls twoicity. This is the contrast between ongoing conscious experience and the direct awareness of past experience. Like Husserl and Heidegger, Brouwer makes the element of time indispensable to consciousness. But the relation between past and present seems to be too unspecific to the task of explaining number. The past is also amorphous, and it has an indefinite relation with an indistinctly bounded present. Time does not seem to provide the definite categories upon which number can be established. Husserl also states that the concept of time is not included in the concept of number. Yet I believe that there is another way of explaining mathematics and number in terms of consciousness. That is, the final boundary of knowledge as number is the final boundary of knowledge as consciousness. Therefore, mathematics, number and consciousness are mutually explicative. We can use the mathematician Frank Ramsey to help us argue this view. Ramsey attributed two criteria to mathematics tautology, and operating at the most extreme level of generality. Mathematics is thereby the most abstract and general form of understanding, constituting a final boundary. Wittgenstein also regarded logic as an indispensable in understanding the world. Yet number also functions as contrast and differentiation that gives meaning to particular objects. Tables and chairs, for example, are differentiated as singular objects through the concepts that we bring to them. In another view, they couldn't be distinguished from pieces of wood or the ground they stand on, and their distinctiveness as individual or singular objects is thereby put in question. My point is that number is constitutive of every object in the world. And to reinforce that point, Kant held that space and time had to be explicable in terms of mathematics. These comments indicate that the final boundary of knowledge can be understood in terms of number, and this account holds not just for human understanding, but for all conscious individuals. So I now want to extend this account to include consciousness. Human understanding as cognition and as an aspect of consciousness has been widely established. It has been established by Kant and by the cognitive non-cognitive distinction in analytic philosophy. Yet there's more in common between mathematics and consciousness than a boundary of knowledge. It is the structural divisibility of consciousness that is also foundational to number. I usually explain divisibility with the idea of a white spot on a white board which thereby can't be seen. Yet I first want to explain divisibility across a much broader spectrum of consciousness. To begin with, there is divisibility between individuals, that you are not me and I am not you. This isn't accepted by Vedic and a few modern philosophers who believe we participate in one unified consciousness. But Bernard Williams gives voice to the modern consensus that individuals are ontologically distinct. Other forms of divisibility include split brains, modalities of mind, and schizophrenia. I can now return to divisibility with the idea of a white spot on a white board which thereby can't be seen. It can't be seen because it needs a contrast like a black spot on a white board. Such contrast is a necessary requirement of cognition and thereby also of consciousness. Further, this is because cognition is a necessary requirement of consciousness. This can be argued on the axiom shared by both analytic and continental philosophy that consciousness is conscious of something, and on this view a brain in a vat could not be conscious. I also often make the point that contrast is foundational to consciousness with the help of Sartre. Freedom and choice are basic to existentialist and Sartre's thought that Sartre traces to consciousness. He makes a close identification between choice and consciousness that he expresses by saying that choice and consciousness are one and the same thing, and that every choice supposes elimination and selection, and thereby also contrast. Yet Sartre goes further to make the phenomenon of choice as selection an ontological property of consciousness. He writes that choice isn't just a preference, but a selection traced back to its ontological foundation. These arguments show that contrast is a fundamental property of consciousness rather than of the world, and at the same time it can thereby be said of number and mathematics as properties of consciousness. I now want to apply these properties of differentiation and contrast to an account of number. Although the concept of zero came late to mathematics, it helps answer the question, what is the number one? And the number one is more distinctly defined in contrast to 0 than 2, 3 or 4. Hegel similarly holds that being must be understood in contrast to non-being. Sartre opts this idea as a property of consciousness in his Being and Nothingness. Last week I argued that data and logical values can be defined at the most fundamental level in terms of contrast, and on the above account, number can similarly be defined in terms of contrast. And mathematics is a continuous binary process of abstract differentiations of numerical units, and that, like consciousness, mathematics is an inescapable aspect of understanding. I've just argued above that contrast is a fundamental property of consciousness. So we can now see that contrast or differentiation is fundamental to both mathematics and consciousness, and that the differentiations of both mathematics and consciousness are fundamental to understanding, and that without both mathematics and consciousness there can be no perception of the world. And this binds mathematics and consciousness into an intimate relation. That is, without consciousness, the category of number, even differentiated as 1, much less 2, cannot exist. The differentiation and divisibility found in the structure of consciousness corresponds to that of number, and that these differentiations are only possible within the boundaries of consciousness. Consciousness thereby brings differentiation, plurality, number, and mathematics into the world. I hope to have shown how consciousness involves divisibility in at least 2 or 3 ways. That is, as a fundamental differentiation within itself, within the world, and from the world. And without consciousness, there can be no differentiation and plurality of separate beings. On this account, the structures of consciousness demarcate the parameters of reality for every conscious being, and differentiation is an inescapable structure that brings both plurality and number into existence. Differentiation is a primary condition out of which consciousness emerges, and it continues to characterize consciousness and the differentiation of the world. The most fundamental differentiation of objects in the world is their numerality as one object. That is, objects exist as one item in contrast to non-existence as 0, before becoming multiples of 2, 3 or 4. And the final boundary of the world as number and the final boundary as consciousness are identical. My interim conclusion is then that mathematics is a creation of mind and doesn't exist independently in the world. My reasons are that the fundamental properties of mathematics are derived from consciousness, and that this account explains both the inescapable objectivity of mathematics as well as explaining the inescapable subjective aspects of mathematics. That is, like intuitive justification, incomplete theorems, and infinite extensions. The immediate objection will be that of the implausibility of the subjective basis for an objective mathematics. It might be contested, for example, that a plurality of objects exist, whether they are observed or not. In reply, arguments against both realism and the subjective aspects of mathematics can be cited. But underlying both subjective and objective views, there are different perspectives and appreciations. To address these leanings, I will review the idea of an obfuscation of consciousness. This is because the final explanations of mathematics above was given in terms of consciousness. In workshop number 9, we saw a number of ways in which consciousness has been overlooked. We did this by looking at theories of mind and consciousness that were inherently confused or limited. These included religion, New Age and Vedantic theories, as well as physicalism and panpsychism. Analytic philosophy and postmodernism also inclined towards physicalism. We also looked at the neglect of value as a constituent of consciousness, and this neglect was evident in religion, ancient Greek and modern thought. In workshop number 10, we examined some of the reasons for this neglect of consciousness. Some of these were mundane, conceptual reasons of history, culture, language and psychology. But I was more concerned in the structural or inherent reasons for the argument for obfuscatory character of consciousness. Firstly, there's the problem of immersion of consciousness in its own transparent perceptions. Secondly, regression is possible due to the graduation of mind in personal and evolutionary development. And thirdly, the problem of attenuated cognition or non-referentiality due to a lack of contrasting background. I won't go over these again in detail, except to note the relevance of the non-referentiality of consciousness. That is, self-consciousness cannot compare itself to other objects of the same type in the same way. That is, I have an immediate and a priori awareness of my own consciousness, but my awareness of other people's consciousness is intuitive, empirical and a posteriori. This point is significant in at least two ways. One, self-consciousness suffers a relative loss of contrast, a feature that is key to this discussion. And two, such error theories of consciousness make us more appreciative of how consciousness is overlooked, and thereby also more appreciative of consciousness contributing to our perception of the world. On that note, we might follow up with a number of difficult, perhaps incomprehensible questions. Are number and mathematics, contrary to appearances, really properties produced by consciousness? Are they so pervasive and encompassing that their parameters are almost impossible to recognize? Do logic and mathematics mark a boundary of consciousness and reality beyond which we cannot make sense? Can we then say that beyond this boundary lies the nothing of total absence, that is, what Sartre called nothingness? Is there an intersection here between objectivity and consciousness that offers a possible unification? And are the final boundaries of number and consciousness mutually explicative? Today's topic has been fairly abstruse, so we could conclude with a brief review. We started with a compelling view that mathematics is objective and universal, but this was put in doubt by Russell's inability to prove basic mathematical foundations. Further problems arose with Kurt Gödel's incompleteness theorem and Alan Turing's discoveries. And many other mathematical anomalies can be found, such as Church's undecidability theorem, Turing's halting theorem and Tarski's truth theorem. These were grist to the mill for Heidegger's and Wittgenstein's anthropocentric theories of mathematics. Frank Ramsey proposed mathematics as a boundary and the most general way of understanding the world. The objectivity of mathematics is an inescapable and most general perspective in terms of number. We then find that contrast is both fundamental to understanding the world as well as a structure of consciousness. Consciousness then becomes a primary candidate to understand both subjective and objective aspects of mathematics. Like mathematics, consciousness demarcates the boundary of knowledge that we can't go beyond. And both mathematics and consciousness are both founded on contrast and differentiality. This leads to my conclusion that consciousness explains mathematics, and that mathematics can't have an existence independent of consciousness. So let me have your comments and criticisms at the meeting or on websites like Zoom or meetup.com.